So today we're going to continue talking about equations. Yesterday we talked about how to solve one- and two-step equations. If you remember, if it's a one-step equation, you're just going to do the opposite sign or the opposite operation of what's being done in the equations so that you're undoing what's been done. If it's two steps, you actually want to do all the addition and subtraction first, then multiply and divide. When we're dealing with multi-step equations, there could be several things that are happening. You might have variables on both sides of the equation. You might have multiple terms that are alike that we need to combine. You might need to distribute. So really what we want to focus on is first seeing if both sides of the equation are simplified before we start to solve. And actually what I do is I cover up the right side when I check to see if the left side has been simplified. So if I just cover up the right side of this equation, I see the expression 6x plus 8. That is as simplified as it can get. I cannot combine those terms because they are not alike. So now I'm going to check the right side. So I see 10x plus 12. That is also totally simplified. So that means I'm ready to solve. So what I'm going to do is sometimes, and these are just little strategies that you don't have to use, but it might be helpful if I just sort of break up my equation with a line. And I want to look and see what I have. 6x is a variable term. I'm just going to write v over top of it. 8 is a constant. Here's my line. 10x is a variable and 12 is a constant. So if you see, I have variables and constants on both sides. And I don't want that. I want them to be separated. Think of variables and constants. They need to be sitting away from each other. Two people that don't get along, they need to be separated. It doesn't matter which side you move your variables to. It's totally up to you. Some people always like to move the variables to the left. Some people always want to try to keep the variables positive and move them to whichever side will allow for that to happen. But really, just pick either work with the variables first or work with the constants. I tend to always work with the variables. So if I see that there's 6x on the left and there's 10x on the right, let's just move all the x's to the left. So I'm going to take this positive 10x and subtract it from the right-hand side so that it disappears. If it's a positive 10x and I want it to disappear, I have to subtract it. I have to take it away. And when I do that, I don't have any variables on the right side anymore because they've been canceled. These are additive inverses of each other. And now I have 6 minus 10, which is negative 4. I have negative 4x, and I'm going to rewrite everything else exactly as I see it. Now, if you see, I still have variables and constants together on the left, and I need to separate them. So essentially, this is a three-step equation because now it's turned into what you saw yesterday. I have variables and constants together on the left, constants on the right. So I'm going to subtract these 8 and move them over to the right. These are additive inverses. They're going to cancel and disappear. I have negative 4x equals positive 4. If I am multiplying this coefficient in this variable, to undo that, I'm going to divide by whatever the coefficient was, because negative 4 divided by negative 4 is positive 1. I've isolated my variable. 4 divided by negative 4 is negative 1. Now if I wanted to show a check for this, I just want to check my work, make sure that I'm right. I'm going to rewrite the equation. So I've got, 6x plus 8 equals 10x plus 12. I'm going to take out the x and substitute in negative 1 on both sides, everywhere where I see that x. And now I'm going to totally simplify using order of operations, the left side and the right side, and make sure that they equal each other. 6 times negative 1 is negative 6. Negative 6 plus 8 is positive 2. 10 times negative 1 is negative 10. Plus 12 is positive 2. So that is the correct answer. Okay, let's look at the next example. Again, let's always start by checking to see if we are simplified. If you just take something and cover up the right side of your equation, and you're just looking at the expression 10, is that simplified? Yes. I cannot combine anything, it's just one term. Now let's go to the right side. Is that simplified? There is a couple things, actually. There are a couple things that need to be done to simplify this. First, you can see there's distributive property. I'm not distributing the negative 5 plus 3. I'm only distributing this positive 3. So this negative 5, I'm going to write down here because I'll get to it later. And now I want to distribute 3 to everything individually in the parentheses. So 3 times p is positive 3p. 3 times negative 4 is negative 12. Now, is this expression simplified? It doesn't look like it. It looks like there are two sets of constants that we can combine. If you see, you've got a negative 5 combined with a negative 12. So if we rewrote this, it would be a positive 3p. Negative 5 plus negative 12 is negative 17. Now at this point, we cannot combine these any further. Variables and constants are different. So I'm going to uncover the left side and rewrite what was over there. And just by taking the time to simplify that right side of the equation, this has become much more simple, much more basic. It's a two-step equation now. So if you think about it, we want to isolate our variable and get rid of everything else that's over here. So we're going to add 17 to both sides. These are additive inverses, so that will cancel. We're left with 27 on the left, 3p on the right. And we're ultimately looking for what times 3 is 27. So when we divide to undo this multiplication, we're going to see that p equals 9. It doesn't matter if p is on the right-hand side or the left-hand side. I want you to try to show a check for this as well. So let me erase where I scribbled out. And we'll start out by rewriting the original equation. We've got 10 equals negative 5 plus 3 times p minus 4. And we're going to take the variable out. There's only one of them in there. And substitute it in. Substitute 9 in for p. And we're checking that everything on the right-hand side will simplify to be 10. So using order of operations, and if you'd like to distribute, you can, but you don't have to. If we just want to do 9 minus 4 first to get 5, 3 times 5 is 15, and negative 5 plus 15 does equal positive 10, so that is the correct answer. All right, if you look at the next, we have two equations over here. Go ahead and try both of these equations. The left-hand, or the first number, number 1, you've got variables on both sides, and number 2, you are distributing. Go ahead and pause this, solve and check these examples, and then you can watch to make sure that you've gotten the answer correct. So pause this now. All right, as I look at number 1, I see I've got m's on both sides. I've got variables, constants, and variables, and I want them separated. So I'm just going to move my variables to the left. If I want this plus 12m to disappear, I'm going to subtract it. And I need to take it away from the m terms over here. I cannot combine constants and variables. So I'm going to take 14 minus 12 and get 2m. And bring down everything else that I see. Now I've got to move these constants over with the constants on the right by doing the opposite operation, which is adding 12. I've got 2m equals 18. When I divide by 2, I'm going to see m is equal to 9. A check for this problem, let me move this out of the way, would look like this. The original equation was 14m minus 12 equals 6 plus 12m. take out your m and substitute in 9. Now you're going to use order of operations to simplify both sides. So I would multiply 14 by 9 first and get 126, and then subtract 12 to get 114. So the left-hand side is going to simplify to be 114. The right side, I'm going to use my order of operations and do the multiplication first, which is 108. 12 times 9 is 108. And then 108 plus 6 is 114. So that is the correct answer. On the right-hand side, number 2, you can see that the left part of that equal sign, left part of that equation is not simplified. So if I cover up the right side and just focus here, I can simplify by distributing 3 to get 9c plus 15. And then the right side is already simplified, so I'm just going to rewrite equals 24. Subtract 15. 9c equals 9. Divide by 9. Again, c equals 1. When you show a check for this one, again, you can distribute if you want, but when you're showing a check, you're using order of operations, so you don't have to. When I take that c away, I want to multiply 3 times 1, but stay in the parentheses. So I'm going to have 3 times 1, which is 3. 3 plus 5 is 8. 3 times 8 is 24, which is what we said it's supposed to equal. So that is the correct answer. Now let's look at this last example. And we've got sort of a few different things happening. We've got variables on both sides. We've got a combined like terms, and we've got distributive properties. So it's sort of everything at once. So I'm going to cover up the right-hand side. And let's go ahead and simplify the left. If you see these parentheses and a number attached to them, we cannot solve the equation until those parentheses are gone, until we distribute. So that's our first step. Let's distribute the 7 to everything in the parentheses. We should get 14p plus 21. Don't forget to distribute the 7 to the 3. And carry down that minus 8. Now you're going to make sure that it's completely simplified. And if you see, it's not. I have 2 sets of constants that really need to get combined because they're like terms. So I'm going to combine a positive 21 and a negative 8, which is going to give us positive 13. Now we are completely simplified. We cannot combine variables and constants. So I'm going to bring down the right-hand side, and when you check there, that's completely simplified as well. So now it's ready to solve. If you look in there, you've got variables and constants on both sides. Anytime you see a variable term, you can write a little v over it if you want. Just a number is a constant. And if you can see, we don't want variables and constants together on the same side of the equal sign. So pick one side for your variables to move. And I'm going to go ahead and move mine to the left by subtracting 6p. I want to subtract. Ooh, that didn't work out nicely. Let's move that down a little bit. I want to subtract 6p because it's a positive 6p and I want it to disappear completely. So I want the additive inverse of it. So now I don't have variables on the right-hand side anymore. I have 8p plus 13 is equal to 29. Now it's a two-step equation. Let's get these constants over with their other constants on the right-hand side by subtracting 13. So that this will cancel. 8p equals 16. And our last step is always going to be multiplication or division. We're going to divide by 8, and p equals 2. We do need you to show a check for this. Now this check is a little bit more involved. Everywhere you see that variable, you want to plug in 2. So I'm going to rewrite the original equation, and then take out the variable. I'll change the color a little bit. And plug in 2. On the right-hand side, again, I'm going to take out the variable and plug in 2. Whoops, ran out of space. So simplify the left-hand side. I'm going to use order of operations and say, okay, 7 times 4 plus 3. Stay in the parentheses, 7 times 7. Multiply, 7 times 7 is 49. And 49 minus 8 is 41. When I check the right-hand side, I'm going to go ahead and multiply 6 times 2, which is 12. 12 plus 29 is 41, which is what we said the left-hand side equals to. So we got the right answer. It's so important to show that check. I know the more involved the equation, the longer the check is, but please take the time to do that, because if you check your work, you're guaranteed 100%. Okay, we're done with today's lesson. You may go ahead and start working on tonight's homework.